Welcome to a video lecture based on control of electric tractive motors. This topic is included in the paper of utilization of electrical power, paper code PE702. Myself, Purnam Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra Sood Degree Engineering College. In my previous lectures, we have already learned about various tractive motors which are generally used for electric traction system. Like DC series motor and compound motors are preferably used for traction motors of DC supply. And in case of AC, we are generally use three-phase induction motors, and AC series motors are also used for traction purpose. But from very beginning, it is very popular that DC series motor, as it can carry a huge amount of starting torque. So the DC series motors are generally preferred for electric tractive motors. In this lecture, we will see that how that DC traction motors or any other tractive motors can be controlled, because for traction purpose, the controlling is very important part for speed control of that particular tractive motors. So we will start with our motor control of tractive motors. Starting and speed control of DC traction motors. A total topic will be not covered in this lecture. I will just briefly start with the control of DC traction motors, and in my next lectures we will also continue with this topic. So starting and speed control of DC traction motors. As we have discussed previously, only DC series motor and compound motors are most suitable for traction purpose. With a DC series motor, the current and torque produced at standstill may be reduced by changing the field or lowering the terminal voltage. That means, for series motor, the current and torque produced will be standstill and may be reduced by using the changing of field or lowering the terminal voltage, or both combining it together. Motors may be placed in series, reducing the terminal voltage of each without loss in external resistance. External resistance may be placed in series with the motors to limit the starting current to desired value. That means we are putting the external resistance, and that is placed in series with the motors to limit the starting current to desired value. Because in case of DC series motor, it is the challenge that at the time of starting it can create a large amount of starting torque, so the starting current is also very high, and by varying the resistance the current may be kept constant. Okay, so we will vary the resistance and current will be kept constant during the notching up period as desired, as the back EMF is being built up. Since the maximum torque while starting demands full field strength, any shunt or reduced field connection are usually thrown out of the action in starting. With the DC compound motor, the start may be made with full armature current. Okay, that is another important part, that for compound motor, the start may be made with full armature current, okay, in series field coils, and the maximum current in the shunt field coils. A starting resistance is inserted in the armature circuit to reduce the step until the armature and series fields are connected across the line. That means we are inserting an external resistance in the armature circuit to reduce this kind of steps and until the armature and series fields are connected across the line. Further, the speed increases is affected by reducing the shunt field currents in steps to the point where the shunt fields windings is disconnected, and the action will be then identical that with a plain series motor. Basically, this kind of speed control is very common for DC series motor and DC compound motors. And this detailed study of speed control we have already learned in the electrical machine topic. So here we will not go through the details one. We are just pointing out those parts which are related to our electric traction motors. So first we will start with the various starting and controlling of DC series motors. So in that way, our first control is rheostatic control. Rheostat means a variable resistance actually. A series motor can be started by connecting an external resistance in series. An external resistance which is called starter in series with the main circuit of the motor. See, this is our motor. In the diagram, this is our motor, this part, and with this DC motor, we have connected rheostat in series with it, and since the back EMF developed by the motor is 0, therefore the resistance connected in series with the motor is maximum and is of such a value that the voltage drop across it with full load rated current is equal to line voltage. And as the motor speed up, the back EMF developed by the motor increases and therefore the external resistance is gradually reduced in order to maintain the current constant throughout the starting or accelerating period. The basic traction motor circuit with rheostatic control is shown in the figure, and this method is therefore considerably loss of energy in the external circuit. Definitely that is the truth, because whenever we are connecting an external resistance, that resistance will definitely do some losses. I square R losses will be there. As the number of rheostatic resistance is increasing, that means R is increasing, so I square loss will be definitely increased in this method. Next one that is very important, that is series parallel control. This is very important method. This is very important. Series parallel control of DC series motor. The main disadvantage of wastage of electrical energy in rheostatic control is partly overcome in this method when the motors are 2 or more motors are there. In case of 2 motors, the motors are first connected in series with each other. See here, we have taken 2 motors and these 2 motors are connected in series with each other. And the starting of control resistance as shown in the figure, the additional resistance is gradually cut out by the controller as the motors attains the speed. Finally, the control resistance is totally removed. So what's happened? Let's see. This is the controlling resistance is connected with this motor. Here 2 motors are connected together and one resistance is connected, variable resistance. And see the total voltage is coming across here between 2 motors and the total voltage is equally divided. Now, these 2 motors will togetherly connected with the variable resistance here, and these 2 motors are equally adjusted with the same variable resistance. That means here we are amount of resistance like rheostatic control that has been reduced to a single one, and the both motors or multiple motors can be controlled with a single resistance. And after it has been adjusted, that part will be removed from the circuit. Then this is the first running position. In this position, for any given value of the armature current, each motor will run at half of normal speed. Okay. Now this is the fourth position. Since there is no external resistance in the circuit, there is no waste of energy, and so motors operate at an efficiency nearly equal to the obtainable with full line voltage across the terminal of the motor. So whatever I have said previously, that when the external resistance will be removed, then the circuit becomes like this. There is no external resistance here. So now the motor will operate with the full voltage supply and there is no waste of energy, which is happening in case of rheostatic control, and that problem has been solved in this series parallel control method. And now the two motors are connected in parallel and in series with the suitable variable resistance R, as shown in figure C, that is we have discussed, and this resistance is gradually cut as the motor attains the speed, and finally when the resistance is totally removed, the circuit is illustrated like this. This is the circuit when our total resistance is removed. Okay. Now our next method is field control. As the speed of the motor is inversely proportional to the flux, as the line voltage is constant, assuming, therefore the speed can be varied by varying the flux. We know that for DC motor, the speed is inversely proportional with flux. Okay. So, the speed can be varying with definitely by varying the flux. If we increase the flux, then speed will be decreased, and if we decrease the flux, speed will increase. In case of series motor, the flux can be varied either by connecting a variable resistance known as diverter in parallel with the series field, or by cutting out some of the series field turns, since in both cases the flux can be only reduced. This method is known as field weakening method, and the speed above the normal speed can be obtained. By using this method, speed can be raised to extended up to 15 to 30% of the normal speed, owing to design the difficulties arising these traction motors. That means we are adding some resistance in the parallel, or we will cut out some turns from the series field, and then the amount of flux will be decreased, and when the amount of flux will be decreased, the speed will be increased. Okay. So this method is known as field weakening method. That means we are reducing the amount of flux. Okay. And in this method we cannot reduce the speed. We can only increase the speed. Okay. So in that way we can control the motor, and this method is also known as field weakening method. Now the field weakening method is now no use of starting purpose. This method is used for increasing the speed traction motor up to 10 to 15% when they have attained the maximum possible speed by series parallel control. And the advantage of this system is that it increases the flexibility of the train utility. That means this method has some advantage, and speed can be increased up to 10 to 15%, but they have to attain the maximum possible speed by series parallel control system. That means we can see that the series parallel control system is the most important part of control in case of traction motors. And the advantage of this system is that it increases the flexibility of the train utility. For instance of city service, the speed required is low and frequent starting and stoppings are required. The equipment can be operated with full field. When the same vehicle has to be employed for suburban and interurban lines where the higher speed are required, it would need a change in the gear ratio. By using field weakening method of speed control, the necessity of changing the gear ratio can be eliminated. Thus, one type of equipment can be used to operate various type of service with reasonable energy consumption. Okay, that is the main advantage and that is the main challenges we need to face when we are using it to different areas like suburban or interurban lines. So up to this is for today, and in next lecture we will again discuss about starting method and speed control of DC motors and other tractive motors, and that part is very important. And this lecture I have taken from the book of J.B. Gupta of Utilization of Electrical Power, and controlling is the main part of any kind of traction motors. You can easily understand that when a train is moving between two stations, frequent stopping and starting and running with different speed because of signaling, and human beings have to take the train, so frequent stoppings will be there. So definitely speed control is a vital part of any kind of traction system. And when we will run a train and we are using the different kind of tractive motors, definitely not only the starting torque and starting current we have to keep in mind, but we have to also keep in mind that how that speed can be controlled. And definitely this is another vital point for choosing a motor as for tractive purpose. So in those motors we have to keep in mind that the speed controlling should be better in case of tractive motors because of the frequent starting and stopping. And we will choose those motors only which can be easily speed controlled and where losses will be very less. So all these points kept in mind, different motors are taken into account for tractive purpose, and for DC purpose we are taking DC series motor and compound motor, and there we have seen mainly three methods here. One is rheostatic control, second one we have seen series parallel control, and third one we have seen field weakening control. And among the most important and most extensively used controlling method is series parallel control, and all the other methods like rheostatic method or field weakening method, there will have some limitations. So definitely series parallel control method is mostly used for railway traction system. So up to this is for today's class, and in my next lecture we will again continue with this topic. So thank you all for listening my lecture.